Okay, so I'm finishing up on chapter 14.7 classwork. I'm going to do 2a and b on one video and then c and d on the second video because the a and d don't take as much time. Okay, so the first part, we have the following information. We're starting with a weak acid with titrating it with a 1 molar KOH as a strong base. And so these calculations are going to be more involved because it's weak and strong. And we know that our acid solution in the flask is 100 milliliters and it's a 0.1 molar. Doesn't matter what acid it is. It is a weak acid. It's monoprotic, so it's got only one Ka value. And it doesn't give us the Ka, but it does give us pKa is equal to a nice round number of 5. Now, I would go ahead and convert. Yeah, I wouldn't. Leave it as pKa. Okay. So the first part says, what is our pH at the volume of 0 milliliters without any KOH being added to our weak acid? And on this problem, because there's no base added, there's no real equilibrium going on except for the weak acid and the water, and the only contribution to pH we have at that time is coming from the weak acid's concentration. So you use the pH equal to the negative log of the hydronium concentration. But because all the hydronium is coming from your weak acid and it's a 1-to-1 ratio because it's monoprotic, the concentration of hydronium is equal to the concentration of your acid, meaning the pH is equal to the negative log of 0.100, which gives you a pH equal to 1 when you calculate it. Okay. So there's our answer for A. pH is equal to 1. Now for the second one, or for B, this is where it does get a little bit more complicated because we have now added 5 milliliters of our 1 molar KOH. So the first thing I would do is calculate how many moles of our base and our acid we have. So we're starting off with 100 milliliters of our acid, and it is a molarity of 0.1. So when you multiply 0.1 times 0.1, it turns out we have 0.01 moles of acid. And if I do the same thing for KOH, I have added 5 milliliters, and it is 1 molar, giving me 0.005 moles of KOH. So yeah, there you go. Okay. So I know that they're not equal at the moment. So it's not the equivalence point. Equivalence point would be where the number of moles of acid and the moles of KOH are equal. But I do know that it's about halfway to the equivalence point, which means that the next one, C, where it's 10 mils, is probably the equivalence point. So I'm going to set up a ice table .